Alrighty, my friends, we're going to show that freezing water is spontaneous at negative 10 degrees Celsius and 1 bar, and we're given the enthalpy change of fusion plus 6.01 kilojoules to melt a mole of water. Okay, there's many ways to do that. I've got other videos in the description below on how to solve this problem, but in this video, we're going to use the fundamental equation of chemical thermodynamics, which is delta G, the change in Gibbs energy, equals the change in enthalpy H minus temperature times the change in entropy S. And in this form, we're assuming that temperature is constant. Now, we're also going to assume that the enthalpy change and the entropy change is the same regardless of the temperature in which we freeze the water. So if we assume that's the case, we'll get this notation here, and bear with me. This says it's the change of freezing, and it's the change of Gibbs energy at our negative 10 degrees Celsius in Kelvin, and it's under standard state, so a constant pressure of 1 bar, and in its pure form. And we're saying that's approximately equal to the enthalpy change at 0 degrees Celsius, because the entropy change, delta H, is the same at 0 degrees Celsius as it is at negative 10 degrees Celsius, which is what we're assuming anyways. This is the temperature, negative 10 degrees Celsius in Kelvin, and change in entropy here. Now, to get the change in entropy, we're going to look at 0 degrees Celsius, which is 273 Kelvin, and at this temperature, the solid and liquid phases are in equilibrium. If they're in equilibrium, then the change in Gibbs energy is 0, and if we plug that into this equation right here, we get 0 equals delta H minus 0 degrees Celsius in Kelvin times the change in entropy, and if we solve for the change in entropy, then we have an expression for the entropy change, which we can plug into this equation right here. And we're almost done, but we want the enthalpy change of freezing. And here, this is the enthalpy change of melting. It's melting because this is positive and it takes energy to melt it. So if we're freezing it, then energy has to be released. So it's the negative of melting. And we can now plug that into our equation, plug it into our good old calculator, and we'll get a change in Gibbs energy of negative 0.220 kilojoules per mole. It's negative, therefore the process is spontaneous, and if it's spontaneous, the entropy change of the universe, entropy change, is greater than 0. We can solve for the entropy change by using this equation here. I could derive this. This is from the second law of thermodynamics. Let me know if you want to know where this equation comes from. But anyways, we can plug in our delta G, and we're left with an entropy change that's greater than 0, and life is good. Okay, good luck on your midterms, final exams. Seriously though, the more problems like this that you do, the better you'll get. This is a super common exam problem. Hang in there, best of luck, and I'll see you in the next video. Cheers.